Welcome to
Nay.
Do it.
Channel Everyone. Okay, deep breath. I am looking at this paper and the title alone is a mouthful. On Information Self-Locking and Reinforcement Learning for Active Reasoning of LLM Agents. Yongqiang. Help, start simple for me. What is active reasoning? Pretend I just learned what an LLM is last week.
Of course, Isabel. Think of it like a detective game. The LLM agent is the detective. Active reasoning means it doesn't just sit and think with the clues it already has. It has to go out and get asterisk new clues. It can ask questions like, was the butler in the library? To gather the information it needs to solve the mystery.
Exactly, and reinforcement learning, or RL, is how we train this detective. Every time it asks a good question that gets it closer to the truth, it gets a virtual reward. The goal is to teach it to ask the smartest sequence of questions.
Ah, got it. So we're training AI detectives with a point system. But the paper says there's a big problem. Information self-locking. That sounds bad. What is the agent doing, putting its own clues in a safe and forgetting the combination?
You're closer than you think, Isabel. The research found that agents trained this way often stop asking useful questions too early. They get stuck. They might ask one or two questions, then just freeze. They stop exploring for new information, and they also fail to properly use the clues they already have. It's a double failure.
It's a major bottleneck. The agent locks itself into a state of low information. Hence, self-locking. The training reward is only given at the very end, for solving the whole task. If the agent gets stuck early, it never experiences that success, so it never learns how to get asterisk out asterisk of being stuck.
Okay, so the feedback loop is broken. The agent is stuck, so it can't learn to be unstuck. But why does this happen? What's actually broken inside the AI detective?
The paper breaks it down brilliantly into two core skills. First, action selection. That's the asking questions skill. Second, belief tracking. That's the updating the detective's notebook skill. You need both to be good.
And they feed each other. If your belief tracking is weak, you don't understand what the clues you have asterisk mean, then you can't ask a good next question. Your action selection suffers. But if your action selection is poor and you don't ask for the right clues, your belief tracking has nothing good to work with. It's a vicious cycle.
So during training, if it starts with a weak version of either skill, it gets trapped in this loop and can't improve. That's like trying to learn to bike on a path that's too narrow to even wobble. You just fall over immediately every time.
Precisely. The standard RL reward is too sparse, too far away. The agent needs hints during its investigation, not just a case-solved medal at the end.
So what's the fix? Do the researchers give the AI a cheat sheet?
In a way, yes. They propose injecting directional critiques during training. These are easier to get signals that guide the agent. Not you solved it, but that question was relevant to the mystery. Or your current theory is inconsistent with clue number 2.
It's like a trainer giving the detective mid-case advice. Good question, that eliminates a suspect. Or hold on, your theory doesn't account for the broken lock. This reallocates the learning signal, helping the agent escape the self-lock and actually practice those core skills.
And it worked.
Significantly, across 7 different test datasets, their approach mitigated the self-locking and brought improvements of up to 60%. It's a simple idea, but it addresses the core feedback loop problem directly.
Wow, so the key was breaking the deadlock by providing more frequent, guiding feedback. It's not about giving the answer, but about validating the asterisk process of good detective work. That makes so much sense.
That's the essence. It's about shaping the learning journey, not just rewarding the destination.
Fantastic. Okay, my brain is officially unlocked. Thank you both so much for walking me through that. This is seriously cool stuff.
Always a pleasure.
Thank you for having us.
And thank you, Asterisk, for watching. We'll see you next time on I Do It channel.